there. My name is Nick Eberts. I'm a product manager at Google, and I work on GKE, fleets, and multi-cluster tools. So today I'm going to give you a demo of a new service we released called Multi-Cluster Orchestrator. So let's get into it. So here's the demo environment. I have a project, and that project's a fleet project. And within that fleet, I have 4 clusters. There are 3 clusters I'm running applications on, all scaled down right now. And then I've got 1 hub cluster, and that hub cluster is where I'm installing multi-cluster tools. Multi-cluster Orchestrator is running here. Also, I've got Argo CD running in that cluster. And this is also the cluster that we're targeting to generate open source cluster profiles into. So what is open source cluster profile? Open source cluster profile is really just a pointer back to a real cluster that we have in fleets. And the idea here is that n number of cluster profiles will make up a cluster inventory. And a cluster inventory is the open source equivalent of a fleet. So the idea is in SIG multi-cluster, we came up with a spec for cluster profile and some rules about groups of cluster profiles being cluster inventories that helps us have an open source standard around lists of clusters. So GKE fleets is going to generate cluster profiles in this standard way. And the multi-cluster orchestrator tool that we built consumes open source cluster profiles, not fleets directly. So let's take a look here. So I'm going to do a container fleet membership list. And there's the 4 clusters. And I'm also showing the labels because I want to point out that this is the label that gives the fleet controller an idea of which one is the hub and which one to generate those cluster profiles against. And now, so if I do a get cluster profiles in the fleet cluster inventory namespace, you can see that I have those same 4 clusters. And if I describe the hub cluster, excuse me, you can see that the labels that are on that membership for hub are also getting propagated here. So the idea here is that we can have a common list to use with multi-cluster tools within the ecosystem that is upstream in Kubernetes and SIG multi-cluster. So the next bit I want to talk about is related to networking. So while multi-cluster orchestrator is going to place workloads in the right cluster within your fleet based on the priorities you set and the capacity that we have, we also need to be able to make sure that you can distribute requests to those workloads once they come online. And the way we do that in GKE is with multi-cluster gateway. So I have a multi-cluster gateway programmed for this inferencing app that I'm using as a demo, but I want to call out that this is special, right? We've not yet released this. This is not just a normal external gateway class, but an internal one. So we have here, I'm announcing a multi-cluster, multi-region internal layer 7 load balancer. So that means that you get a private IP and you can distribute work to clusters that are running in private mode. This is super unique to Google Cloud. No other cloud has this ability to have global networking, and certainly not the ability to have a private IP in front of multiple applications running in multiple clusters across multiple regions. Another thing that we released to make this a little bit more useful is within the backend policy spec that you bind to a gateway, you now have the ability to set a preferred backend. So the preferred backend for this workload is US West 1. And so what that means is instead of using the default least latent routing algorithm or using fancy cookies or headers, you now have a really easy way to say, hey, you know what, send all traffic to clusters in this region or this specific cluster, and only shed to other clusters when you exceed the max rate per endpoint. So what that means is that if there are other clusters within the fleet that are behind this multi-cluster gateway, traffic is going to prefer this region and only shed when that RPS is exceeded. And if there are only clusters in the US West region, traffic will just get sent to that region. Okay. So the next bit is the multi-Kubernetes cluster placement. Now this is a CRD that allows you to interface with MCO. You make one of these per workload, as you can see here, right? You have to have workload details, deployment name, HBA name, namespace. And then the other thing that's interesting is you're able to define a list of rules. And in this example, what I'm doing is creating a list of clusters where the lowest on the index is the highest priority. So US West is going to be the primary cluster, and then the next preferred cluster is East, and then the last preference is Europe West 4. So this is how MCO is going to understand what your preferences are for a workload and marry those up with actual capacity and make a decision. And MCO's real job is not to actually be a CD tool, right? We didn't want to build yet another CD tool. It is a scheduler of sorts. It's making a recommendation to a CD tool on where you should put this workload. So you can see right now, I have this recommendation for US West. Now, in this case, we're using Argo CD. And the way that you typically do multi-cluster applications with Argo CD is via application set. And you can see here, I've got an application set, and my team wrote a generator, a plugin, if you will, that allows you to program this application set to watch for the placement recommendations from MCO. So you can see here, this is me calling out the Argo CD MCO placement plugin generator, and here's the parameters that it needs, which is the actual name of that placement object and the namespace in which it lives. And so Argo CD, in this case, that application set, knows that it only needs to create an application for the one cluster right now. So what about the actual application? Let's just describe it real quick. It is a VLLM inferencing server hosting Gemma 3 1B model. And just to show you that there's no smoke and mirrors here, I'm logged into a Bastion server. So this is just a GCE instance that's running in the same VPC as my load balancer and clusters. And I'll do a hostname -I to show you, excuse me, that it does resolve an internal IP address. So this is on the same network that everyone else is on in this demo. And then I can do a curl just to show you that it's working. So I'm going to ask it, who is Nick Eberts? And it very rarely does it say amazing guitar player, magnificent presenter, but it seems like this model seems to think that I am an enigmatic American author known for unsettling and atmospheric horror novels. Like, there's no Nick Eberts that does this in the world. I don't know. I think this is a hallucination, but nonetheless, it works. So the next thing that I will do is throw some load at this endpoint. So we'll use, actually, before I kick that off, let's get a watch loop going. So I'm gonna watch for those placement recommendations. So I'm watching the status of that placement object, and I'm running it in. You can see right now it's still just returning that one US West cluster. So if I throw some load at the system, let's see what happens. So the first thing that'll happen before another recommendation comes from MCO is the HPA on the primary cluster will try to scale out once there's enough load that hits the system. And you can see it's trying to scale out right now. If the HPA can't scale out quick enough, which means that the underlying cluster autoscaler can't add a node with a GPU on it fast enough, then the MCO is going to catch that signal and schedule or make a recommendation for another cluster to run that workload on. If indeed there's capacity available, it'll just scale out. Eventually it'll hit this 3-pod limit though, either way, and induce a pseudo stock out in which the MCO will catch and say, hey, there's more load than this one cluster can handle. Let's add another. So let's see what happens here. Just refresh. And it's making a recommendation for a second cluster. You can see that here, which then triggers Argo CD to add a second instance. So you can see it's adding one for US East right now, and it's deploying the Gemma server into this other cluster, which should show up here now. And voila, look at that. We just chased some capacity. We had a stock out of some sorts local in the primary cluster, which MCO caught and then instructed Argo CD to deploy the Gemma application in one of the backup regions. So that's really cool. That's how fast it works. We want to make all of this tunable so that you can decide how quickly you actually want to or how long you want to wait before you add the second cluster. We're not there yet, but for now, we've got some decent defaults. I'm going to put a stop on that load to show you what happens on scale down now. So I'm canceling the pay from running, which should immediately reduce the load being sent through the system. And look at that, it actually found capacity too. So now I have basically 3 nodes running GPUs in my primary, 1 in the secondary. And now we'll just show you the scale down behavior. So now that there's no load, what's going to happen? What you're going to see is, for one, the HPA in this primary region should scale down because there's no load on the system anymore. And then after some time, MCO is going to observe that the secondary region doesn't really have any load on it, and it should, in fact, remove the deployment. Now, this takes some time. We don't do this quickly because we don't want to thrash. So I'm just going to keep on watching this while loop. All right, you can see that it's scaled down. The HBA has done its job in scaling down the primary region back down to 1 because, again, there's no load on the system. we're conservative in waiting to shut down a region, just in case in real life there could potentially be like another influx of work and we don't want to shut down the region prematurely. But again, we're going to make this tunable so you can decide how long a cluster should stay up when there's no load on it. But pretty shortly, the MCO should make a recommendation to remove that East cluster. There you go. It made the recommendation to shut down that East cluster. You can see here, it's getting closed off, right? So that application is getting deleted, which means the application is going to get deleted. And as soon as Kubernetes does its job, it's gone. Okay. So that's pretty cool. So remember what this demo showed you, Multi-Cluster Orchestrator, which is a open source tool that works on open source cluster profile, that integrates with fleets and allows you to define centrally on a hub cluster a workload's priorities across your fleet as far as placement. And then it constantly watches that workload and makes recommendations as to which clusters it should be deployed to a CD tool. And that works on both scaling up when there's a spike in demand or a capacity issue, and also scaling down when things are underutilized. So please give it a try. Feel free to reach out to me with any kind of questions. We are pumped for this. Thank you for your time. Ciao.